This conference will now be recorded. This conference will now be recorded.
Hey, hi, Funny. Okay, let's start the session. I hope, hey, good morning, Funny. I hope you guys can see my screen. Is it visible?
Ye- Yes, yes.
Yeah, okay. Sure. So today we're going to start with the topic of the optimizer. Today and tomorrow we're going to spend a lot of time on the optimizer and various scenarios in. Uh, uh, hey, Sainath. Sainath, am I audible to you?
Yes, sir. It is audible.
Yes. Sainath, can you please tell me your background? Are you from APO or?
It's SDNMM.
Sorry?
I'm from SDNMM. I handles SAP SDNMM.
Great, great. Sure, yeah. So I hope my screen is visible. So just a small recap, guys, on what we did yesterday. So so we continued with the heuristics and then the supply propagation. The session was has been recorded and it is available to you guys to refer it back. So yesterday, I think we have touch based on the adjusting the plan. So why we want to adjust the plan? Because we tell it to the system that there are some quotas that the heuristic or supply propagation has to respect. And but sometimes if the planners has more information on any particular node, on any particular data point, he can very well go and adjust the plan. And so to adjust the plan, there are adjusted key figures are available. So planner has to go and maintain the value that he wants for the adjusted key figures and run the heuristic. So the results would be same as what is being maintained in the adjusted key figures. So we have seen this, how to adjust the plan. And sometimes because as we have seen that heuristic is mm, infinite supply and demand without any shortages. So even though you adjust the plan and the demand is of 1000, you adjust the production to just the 500. So but still heuristic will say that okay, you adjusted the plan to 500, I'll stick to that 500. I'll produce only 500, but still I will ship 1000 to the customer. And what happens to that remaining 500? That would be, visible in the negative projected stocks. That means the heuristic is saying that this particular locations need an extra of 500 stock to meet the demand, but I am not going to wait for that stock. I'll go and fulfill the demand, and you can see the shortages in the negative projected stocks. So So that is what happens with adjusting the plan, and when we do the adjustments, we might lead to scenarios called oversupply scenario, or undersupply, insufficient supply. Sometimes in the process of adjusting the plan, or maybe constraining with the lot sizes and etc., that might lead to the oversupply or insufficient supply. So in those cases, we have to use a functionality called receipts balancing. So with the receipts balancing, the heuristic in supply propagation will have an intelligence not to do the oversupply or insufficient supply, but to match the demand exactly. So we have seen this yesterday. And then to do this receipt balancing, we have seen that we have to do some changes in the master data. We have to do a change in the heuristic algorithm profile itself. There is a checkbox which we have to say that the checkbox the receipts balancing, then the heuristic algorithm will respect this functionality, and then it will balance out the receipts. And what else we have seen yesterday? Hmm. One second, guys. Is it visible to you guys? The screen? Yeah, and then we have seen the validities. We can go and say a particular source of supply is not valid for a particular duration. We have seen this. When I say source of supply, it is covering all three sources of supplies. That is the customer source of supply. That means the customer connecting to a location. Here, Amazon is connected to warehouse, and it is shipping a product called S12. So there is a source of supply for customer. That is a customer source of supply. Here we can maintain what sources are valid and what sources are not valid. For example, Amazon can have two locations are connected, warehouse 1, warehouse 2. In quarter 3, warehouse 2 is not valid. You go and maintain the records in the master data, say that this ship from this location connecting to this customer Amazon for this product S12, it is not valid, and you give a date that from this time period, quarter 1 of 2019 to quarter 3 of 2019. That means it is valid only between quarter 1 and quarter 3. In quarter 4, it will be invalid, and system will not push the customer demand onto the invalid location, that is warehouse 2. And what happens then? What happens to the quotas that we maintain? Because if there are two warehouses, I might have maintained zero point 0.3 and zero point 0.7 ratios. But now if you take off the warehouse 2, that quota would be spread across the available valid sources of supply. So yeah, that's one customer source of supply. Next is the location source of supply. So that is between the locations. So for this warehouse 2, there are two sources of supplies. It is connected to plant 1 and plant 2. Again, you can say that plant 1 is not valid for so and so duration. uh, Heuristic, supply propagation, or even optimizer will respect that, and then it will not consider that line of network for for the supply plan. Third source of supply is production source of supply. That means how the production is happening inside a manufacturing location. So inside this plant 102, for the product S12, there could be multiple bombs, multiple source IDs. In IBP, we call it as source ID, production source header. So you can create multiple production version 1, 2, 3, and every version can have a different bomb structure to it, different consumption rates, etc, etc. So you can go and very well say like within this duration, this production version is not valid. Then the supply planning algorithms will push the demand accordingly to the valid sources of supplies. Okay. And then lot sizings we have seen maximum lot size, minimum lot size, and rounding values. Next, we have seen the supply propagation heuristic. So the difference between the supply propagation and the normal heuristic is um, only the available supply is propagated. That is the only catch. In the heuristic, even though the supply is not there, still the system would meet the demand without any shortages, but the shortages can be visible inside your supply chain network, maybe at a warehouse or maybe at a DC or at a plant in the negative projected stocks, etc., etc. But whereas with the supply propagation, only the available supply will be met. So with supply propagation, we can see uh, where the shortages are coming in and which customer products are not being met, and then you can work on those particular data points and then see why the issue is coming in. Any insufficiency in supply can happen by adjusted key figures or no source of supply is maintained, or maybe the lead times are high, etc. So that's what we covered. So today we'll start with the optimizer, guys. So yeah, optimizer is another algorithm available inside the supply planning module. So optimizer works in a complete different way. um, so yeah, depending upon the business requirement. So in all my three implementations that I have done in IBP, the customers are also using heuristics, and heuristics are still being widely used. Optimizer also there, but heuristics are also being considered. So it's not just that the optimizer is all about the supply planning. So yeah. So okay, now let's come to the supply planning. So supply planning optimizer will, because the name itself is saying optimal, it comes up with an optimal approach. hmm? Right. So for example, here, if we take the same example in here, simple network, there's a demand of 100 at Amazon. So now this is my network. There's a warehouse, there's a plant one, there is a plant two. Okay. Now how I can supply the demand of 100. So I'll say plant one produce zero, do all the production in plant 102, or maybe plant one you do 10, plant one or two you do 90, or you will say plant one do 50, plant 102 you zero do nothing, and warehouse you get 50. Let's say the warehouse also can get from another uh, some kind of a co-packer or someone co-manufacturer, something. So yeah, if I can go with these combinations, right? I mean, I can come up with n number of supply plans just for this demand quantity of 100 for a particular time period, right? There could be n number of options, but out of these n number of options, and let's just say that obviously there is a cost element attached to everything, right? So to produce something, there is a cost that you incur. There's a fixed cost and there is a variable cost, and then to produce 100 here and then ship 100 from here to here, again, transportation cost, fixed transportation cost. And then to to store some stuff here, you'll have inventory holding costs and etc. So there are costs at at every node, and then to do the shipment of 100, you incur all these costs. So if I come up with all these combinations, the plan one is a 0 to 100, produce 0, produce 100. Plan 2 is produce 10 in plant 1, 90 in plant 2. What is plan 3? Plan 3 is plant 1 do 50, plan 2 do 0, but do some external manufacturing of 50. So I can come up with n number of plans. But out of this n number of plans, there, and every plan will have a cost that you incur. And out of these n plans, there would be one plan where it is the cost optimal. That means it is a least cost. That is the optimal way to do. So optimizer will give you that optimal way of doing your supply plan and meeting your demand. So that is what optimizer is all about. Optimizer is an approach to find a cost optimal supply plan. Now the catch here is that you have to specify all the costs, and then there are so many costs. You have to there are costs like uh, uh, see, some costs are direct, some costs are indirect. For example, inside the production facility, there is a resource that is producing the finished good of S12, uh, and then the resource will have a particular capacity. When the production is happening, that capacity will be consumed. You can also there is another key figure called as a minimum resource capacity utilization. That means you can say that inside my plant 102, you do minimum resource utilization. So you say that please do minimum of 60% on this resource. Okay, so that means that there's a lot of setup cost involved. Once you bring out a big production a resource, and then you're setting up and you're doing all that stuff. But once you start with it, you have to do a minimum of this much, right? So now how will you tell it to the system that just please stick to this value? I'm telling that in this particular time period, maybe on week 10, you do a minimum of 60% in here. So for this, there is something called as a violation cost. You say that minimum resource utilization violation cost, right? And you give a very a decent value that if you are not sticking to the minimum consumption, and if you are violating it, you will incur this much of cost, like $100 or something. So we are actually so what I'm trying to say here is that we can introduce costs in many different ways and can influence our supply plan. Some are straightforward costs, like what is the transportation cost, what is a inventory holding cost, what is a production cost, fixed cost, variable costs, etc. But there are some stuff which are like kind of a indirect penalty costs, and it's kind of a penalty cost. I mean, if you don't do it, you incur a penalty to it. So you can also introduce these kind of a costs into your supply chain network. You maintain these costs at a particular locations that you want. For example, you maintain this minimum resource utilization only at a particular plant, and and then run your optimizer. It will give you a cost optimal results. So that is a optimizer of what it does. But just like the heuristics, in heuristics we have seen, right? So heuristics works in a particular way. There is an algorithm that is written. The system follows that algorithm. Obviously, it's a mathematical algorithm. Uh, there are some quotas, etc. But we have introduced some constraints into the heuristic run, and you know, uh, deduce the desired results. For example, adjusted key figures are one such. We have seen it. So we specify that this particular thing, this is my adjusted value. Please stick to it. Don't do your mathematical quota calculations. Just please stick to it for this particular part of my supply chain, and only on this particular time period. So you can very well influence the heuristic. You can very well influence the supply propagation. Just like that, you can very well influence your optimizer runs. But here the influencing factors are so many, and the optimizer the variables are so many. So here with the optimizer, you can get the desired result that you want from the system. Okay, so now in the optimizer there are three kinds of constraints. Constraint is a condition in my supply chain. And when you do your supply plan system, please respect my conditions. So I have a particular condition, you respect that, and you give me the result accordingly. So now, there are three kinds of constraints: hard constraint, pseudo hard constraint, soft constraint. Let's go through the theory, and then we'll get into the system, and then we'll, as usual, we'll come up with lots of scenarios, and we'll execute every scenario by scenario, and then we'll see the influence of all these variables in our supply chain. Okay, let me do a refresh here, otherwise I think this get. Yep. Optimizer treats various constraints differently depending on the type. Yes, so it treats them differently depending on the type, right? um, for example, you know so um, yeah, I think, yeah, let's complete the theory, then I think we'll cover everything in the theory itself. Yeah. Okay, there are different constraints, various constraints, and optimizer treats them differently depending on their type. Okay, so this ensures the existence of a solution, but also offers the best possible performance, right? Constraints derive from master data. For example, sourcing options. So we have seen customer sourcing, location source, production source. So the constraints derive from the master data, or representing the upper limits usually cannot be violated. Constraint derived from transactional data. For example, demand key figures can be violated if necessary. So some can be violated, some cannot be violated. For example, if you for example here, if you don't maintain a source of supply for this warehouse, then how the production will happen? It cannot happen, right? So that's kind of a master data thing, and then system has to follow that. But whereas with the transactional data constraints, they can be violated if necessary. But yeah, now let's get into the every constraint and see in detail what is a hard constraint. Constraints which are always adhered to, they are called hard constraints, and optimizer never violates these constraints. That's a that's a crux of the hard constraint. Optimizer never violates these constraints. Next category, pseudo hard constraint. So pseudo hard constraints, optimizer will violate, but if it violates, it incurs a very high penalty costs. And then the second bullet point here, optimizer violates this type of constraints only if it cannot find a feasible solution that respects them. If it doesn't find any feasible solution, then it's no other way. It has to violate the pseudo hard constraint, and so that it can come up with some kind of a feasible solution, some kind of a supply plan, so that the demand can be met. Soft constraints, like pseudo hard, soft constraints can be violated, and their violation induces costs for soft constraint violation are meant to represent the financial impact of not respecting the constraints. So soft constraints again are, they can be compromised, but you can definitely prioritize your soft constraint by maintaining a very very high costs, and then the optimizer will respect that particular soft constraint, because the violation, the cost that you maintained are so high. So we'll see it in detail, what key figures are there under all these hard constraints, pseudo hard and soft, and we'll also have some demos on it. A solution is feasible for the optimizer when it respects all planning constraints. Yes, a feasible solution can contain non-deliveries. Yes, exactly. So sometimes, like just like the supply propagation heuristic here also in optimizer, if you say the Amazon, the customer Amazon, the demand is 1,000, it will not meet the demand of 1,000 all the time. If it is not feasible to meet 1,000, it will not meet. Feasible, when I say feasible, two things are there. When I say feasible, that there is no capacity, you cannot produce 1,000, so that is one. So you cannot ship 1,000 to Amazon. Next thing is that I can, to produce 1,000, to produce 500, it is fine. I incur very less costs. But to produce 1,000, I have to do more shifts, and then the cost that I incur is so high, the inventory holdings are so high, etc., etc. So I end up in wasting a lot of time, and now to ship 1,000 to Amazon customer, it is not viable. It's not commercially viable to me. So that's why it is not feasible. So that's why I'll not do 1,000, and I can just do 500 because that is in my range. I can make some money, or there is some profit that I can see if I just do only 500, and if I can just supply only 500 to the Amazon customer. So these kind of non-deliveries will definitely happen. Okay. And um, you see, there are like these kind of stuff, like not fully satisfied demands, safety stock constraint violations, or violate other soft constraints. So if these things are happening, that means it's not a feasible solution. Optimize violate soft constraints if they conflict with hard constraints, for example maximum lot sales, or if the violation is more cost effective. Mhm. So now just I have listed down what are the hard constraints, what are the pseudo hard constraints, what are the soft constraints. Okay. But I think, yeah, let's see this. So the optimizing modes, there are two modes. One is profit maximization, and next is a delivery maximization. Now let's see what is a profit maximization here. So when you run your optimizer in profit maximization mode, what does it mean? So I'm in the web interface now. I opened SNOP operator profile. You just see here. This is app where you maintain all your profiles. I'm clicking on new. That means I'm creating a new profile, optimizer. So I need to give a name, ID, and what planning area it is belonging to, and what profile, etc. So under here, optimizer parameters, there are all these parameters that are available. So under the general, there are these important things that are maintained. First is maximum solving runtime for optimizer. This is in seconds. That means it is 300 seconds. That means it is 5 minutes run. This profile can run for 5 minutes. 5 minutes, it will try to come up with the best optimal supply plan, and it need not be 5 minutes. 5 minutes is a maximum limit that we say. So it gets done in 30 seconds or less than a minute if it is a very small supply chain network. Two modes: profit maximization mode, delivery maximization mode. What is a profit maximization mode? In this mode, if you create your profile in the profit maximization mode, if you run the optimizer in profit maximization, so it maximizes the profit. Now what is profit? Profit is a difference between total revenue, overall cost. Now what is total revenue and overall cost? Total revenue is calculated as sum of revenue of all products sold to market. The revenue of each product is calculated by multiplying its sales price, that is non-delivery cost. So there is a key figure called as a non-delivery. That is an important one in the optimizer. So that is I would say that important one. So you have to maintain a very high non-delivery. Then only optimizer will think that it is business viable to you know mm, you know come up with a supply plan for that product. So the sales price multiplied with the quantity gives you the revenue, but the sales price is non-delivery. That means the non-delivery cost, that means the cost that I incur if I don't deliver it. Amazon needs I mean, if I don't sell one unit of product to Amazon, if I give non-delivery says 900, that means I'll incur $900 if I don't give this product to the customer. So that is a non-delivery. And what is the overall cost? Overall cost is comprising of the production, inventory holding, transportation, and cost of all components. Like to make our smartphone S12, it requires all the chip and battery, earphones, etc., etc. And then there's a cost involved to everything. So the product cost also is so high. So now it does the difference between the what is the revenue that I incur if I do a supply of it, and what is the cost that I incur. What is the difference? That is my profit, and it tries to maximize the profit. So now the customer demand for an unprofitable product remains unsatisfied. This is a key in the profit maximization. And now see the elaborate. If the total cost of the finished good is higher than the sales price, the optimizer chooses not to deliver and therefore not to produce or transport this product. So that's it. So that is a profit maximization mode. Uh, and what is a delivery maximization? Delivery maximization means that it wants to deliver as maximum as possible. So there, the cost will still impact, but the kind of the purpose is to do as much as possible. That is the delivery maximization. So, and in the back end, what just happens is the moment that you say that this is delivery maximization, system just assigns a very high non-delivery cost in the backend. Now it will not read what cost that you are maintaining in the key figure called the non-delivery cost rates. But in the backend, it gives a very high key figure, like it is 9999 something something. So it gives that very high value to non-delivery. That means I'm incurring this much of big $99,999 dollars. So that means optimizes things that okay, then yeah, I have to come up with a supply plan for this product, and then I have to maximize my delivery because I'm incurring so much of costs if I don't do a delivery for it. So yeah, so that's how the the optimizer works, in a nutshell. So now let's see the hard constraints. um, the following master data types and attributes are hard constraints for the optimizer. As I told that some data points will be read from the master data itself. For example, the sourcing rules, you know how the customer sources are maintained, how many locations are there, how many location sources are there, how many production sources are there, lot sizes, validity of sources. So we have seen it here. If you say one source is not valid, then that's a hot constraint. So system will not push a demand to that invalid source, and it will not come up with a supply from that invalid source. So there would be shortages, kind of a hot constraint. Initial inventory, that means how much of inventory is lying physically in the locations. Usually it comes from S4 system through an interface, and the interface runs every day, and then you will get the initial stock. Maximum number of periods that demands can be delivered late. We'll see that. I have a scenario for it. We'll run it today. The following key figures are hard constraints. The key production resource capacity is a key here. In the other two algorithms that we have seen, heuristic and supply propagation, they really don't care about the production capacity, that how much capacity is there to produce. So but whereas optimizer respects it, and it's a hard constraint. So if the capacity is done, if it is exhausted, then it will stop the production then and there. So you will not get anything more. So you will obviously end up with shortages if you don't have enough production facilities, or if you don't have any other external vendors maintained. So production capacity is a hard constraint. We'll see it. I'll have a use case for it also. Next is aggregated constraints. Hmm. So aggregated constraints. What is aggregated constraint? So whatever constraint that we are keeping, you see, we are keeping at a particular node level, right? So here we are saying that plant 101, warehouse 2, you can only do a shipment of 100. That is a constraint that I'm keeping. So but with the aggregated constraints, I can keep at an aggregated level. For example, S12, there is a product called S12, S12A, S12B, S12C, etc. Three product IDs, they all belong to something called as, let's say, product family. Okay, and all these three products will get shipped from plant 101 to warehouse. This is an three records are maintained between plant 101 and warehouse. now when you maintain a transportation constraint, you will go and say that my S12B product do a shipment of only 100. That is the normal constraint that you keep. But if I'm saying aggregated constraints, you actually go and say between these locations in the product family, let's just say the product family is S12. So I'll say that my S12 product family just do a minimum of 100. So if you keep a constraint at an aggregated level, and when you run the supply planning, so system will respect it. And then if you actually open at the individual SKU level, if you open S12A, S12B, S12C, the summation would be a minimum of 100. And if you say maximum of 500, then it would be the transportation would be in the range of 100 to 500. That is an aggregated constraint. And aggregated constraints can be maintained for transportations, for productions, for inventories. So you can say that this warehouse, it can store, like, let's say 15 SKUs are there. So you don't have to go and say, like, that there is a particular uh, uh, you know uh, you know, um, you can say that this warehouse um, cannot hold more than of 100 units for S12A or S12B. So that is at a detail level, that is at a base level. But with an aggregated level, you can go and say that I don't care about unique SKUs, but I'm keeping a constant and aggregated level. So and let's not store more than these many products inside my warehouse location. Run your supply plan, the optimizer will give a results, and it will meet the aggregated constraints that you maintain. Same with the production. 10 SKUs are getting made inside plant 102. Now you can go and put at a plant level and say this plant overall production should be less than this much. Optimizer will respect it, and etc. So I mean, just imagine, guys, imagine the possibilities of what all we can achieve with aggregated constraints. For example, there is one S12 product, S12 product family, and then there is something called L12, which is like laptops. We say S12 is smartphones, L12 is laptops, and there is something called T12, that means tablets. You're making all these gadgets inside your plant 102. So, and then S12 will have some kind of a 10 different mobile phones, 10 different queues. 10 different SKUs have 10 different production versions. They all are getting made inside 102. Laptops, again, 5 different varieties in your laptop, 5 different SKUs. They all are making inside plant 102. Tablet, 12, 3 different kinds of tablets, and then you're making inside plant 102. And then, optimizer will come up with supply plan for if the demands are there for all S12. Yes. So, um, where were I? Yes. For Amazon customer, the demand is there for smartphones, for laptops, for tablets. Let's say supply plan come up with optimizer will come up with a supply plan for all the smartphones, laptops, tablets. Production will happen for all the smartphones, laptops, tablets. But if you don't want to do the production for laptops and tablets, what you can do is you can keep an aggregated constraint. You will go and say that for this family of L12 and a T12, my maximum production is 0. So you're saying that the maximum itself is 0. That means the optimizer doesn't have any other option but to stick to the S12 and dedicate all its production to the family of S12 SKUs, right? So that is an aggregated constraint. So it's a very, very powerful feature. So like in all my last two projects we have used the aggregated constraints. We'll see it. I have a lot of use cases for it. How to model aggregated constraints and how system will respect it. So next is a maximum key figures. How much of maximum customer transportation can happen, maximum transport, maximum production, maximum external receipts. So when I say maximum, these are at detail level, guys. So just please understand that when I'm saying maximum production, so this is at product level. location level, and also source ID. If you don't want system to give more than a x of production plan, you have to maintain data at this level. You have to go in detail. You have to say what product in what location and what is a production version and what is the value. So that is a detail level that you have to go. Whereas with aggregated constraints, you can actually go a level above and then you can keep the constraints there. So yeah, next are the pseudo hard constraints and soft constraints. um, I think we talked a lot, so let's go to the system and do something. So I don't want to bore you guys with a lot of theory. So again, came to the planning view. Now let's run some algorithm from some optimizer runs and see how it works. So same network, Amazon connected to warehouse, further connected to two plants. Okay, so now see, maintain yesterday also, if you remember, we maintained the consensus demand and no costs. Heuristic, no costs, nothing. Heuristic will not read any cost. Heuristic will not understand any costs. So now if I take off this non-delivery, you see, this is what we're talking about. If there is no non-delivery, system will not do anything. So these are the previous run results, and so now let me take this off. Running the optimizer in the advanced. Okay, it is finished. See, the receipts are gone. Um, have you guys touched upon the local member key figure? Have we covered that? I think we covered, right? Can you please? Uh, hey, anyone, please confirm that. Have we covered the?
I don't think so. Maybe we did not remember.
Hey, anyone? Have you guys remembered? Okay, fine. So I'll refer back to my slides. Um, refer back to my slides and. Hey, 1 second, guys. 1 second. Hey, hello guys. Hey, sorry, I mean there's some internet disconnection happened. One second. Uh, have I lost anyone? So, I mean, who's there in the call? Madhu, you there?
Yes.
And Funny, Funny, can you please talk and confirm? I'm having some network issues, guys. Funny.
Hello.
He said yes in a chat.
Okay, okay. He said X in the chat. Okay. Hey, sorry guys, some internet connectivity. And Srinivas, Sri.
Yes, I'm in a hall.
Okay, thanks guys. I know you guys are on the call. Just checking. Vijay.
Yes, yes.
Hey, thanks, man, Vijay. And I'd say IBP session. I think it's Anji. I think Navin is the coordinator for us. So in SAP IBP is me. Okay. Hey, just a minute, guys. There's some internet issues. Just please be on hold for a minute, please. Hello.
Yes, Venkat.
Hey, sorry guys, sorry. 1 second. Hey, sorry guys, some network issues from my side. So yeah, where were we? Anybody?
Local key figure something.
Mhm. Hey, yeah, thanks. So I'm thinking that we have covered the local key figures already. So because a key figure is a configurable element, we configure a key figure and then we specify what is the base planning level and the calculation logic and etc etc. But whereas a local member is local to just this planning view. So let me just create. I'm creating a local member, guys.
Yes, sir. This is covered actually.
Yeah. Oh, yes.
You do a local calculation, and but this value is not going to save it for you, but this value is going to
Hmm.
just display for you.
Exactly. And then you want to do any quick analysis. So
So
yeah, here
which
we can
values
see
are
that.
removed?
Sorry, what is it, guys? Someone is saying something. Hello. Okay, yeah, fine. So yeah, what I'm trying to do here is that showing you the distinction between the heuristics and the optimizer. Whereas a heuristic, if you just give a demand element, it would take the demand element and it would propagate the demand to your supply chain network and comes up with the supply plan. Supply plan, transportation plan. Supply plan means transportation plan, the production plan, and the inventory projections, etc. But whereas with optimizer, you have to play with the costs. So I didn't give any cost for the non-delivery. That's why it was like shortage. I mean, there's a shortage of 10,000. But now I maintain some costs here. So there's a non-delivery cost rate for customer demand. So I give a very high cost. Let me just copy this cost. The current week will now we cannot change it. Running the optimizer again. So you can see that the customer receipts for week 20, it gave 8,200 that it can meet, and there is a shortage of 1,800. Now let's see what's happening at our production locations. I think it is because of the unavailability of, or let's go to the capacity view here. So yeah, wow, see here, I mean the utilizations, capacity utilization key figure, it's all 100, 100, 100. So here in the capacity supply, it is 24. That means 24 hours is the available capacity on this resource called RES 101. And that RES 101 resource is being extended to plant 101. And the available is 24. And the usage is 24 hours. So the entire 24 hours is being used. That's why utilization percentages are 100, 100, 100. So if you guys remember, we maintain that in, first we maintain the resources here, and then we extended the resources to the locations. And then there is this production society, and then so I'll open this resource level master data. So this is where we maintain all the resources. So you see here RAS 101, RAS 102. We first maintain the resource IDs here, and then the description. And then we extend the resources to the locations. So you see here, this location plant 101, plant 102, resources are 101, 102. Capacity supply is 24 here. And you guys remember the time series indicator, the master data element? When you say it is a time series indicator, that means the planner can maintain a time series value. So here capacity supply is 24. That means it is 24 hours and it remains 24 across the time horizon because it's a master data element and it is a static value. But the moment I see that I maintain X and X here, that means I'm saying the capacity supply is a time series indicated. That means we're telling it to the supply planning that, hey, please don't read the capacity supply from the master data element. Instead, read it from the key figure, a key figure with the same name called capacity supply. So if it is a key figure, we know it is a time series element. So it will have values across the horizon. And we can very well go and change the different, we can change the values differently for the different periods. I'll go in here, I'll say week 21, it is not available for 24 hours. There's a public holiday in this week. The capacity will come down to 20 hours. And then, I can run the supply plan, and now I'll get the results, accordingly. So so next is a constraint type. That means whether it is a F, or F means it's a finite. That means the capacity available is finite, it is not infinite. So if you leave it blank, that means it is an infinite capacity. So that means there would not be any restriction, and then it would do whatever demand is there. So if I made it as I, system would do the demand of 10,000 and also ships the demand of 10,000. You want to try that, guys? Let me change that, and let's see it. Location resource. Let's make just the resource one. I'm taking this off. I changed the record. Now I'll rerun. Now let's see what happens. Now this time the demands would be met. The shipment would happen for 10,000. The production across the locations will also be 10,000. So you can see the demands are met, 10,000, and the shortage is 0. Now let's see what's happening at our production locations. So, okay, so you see here, the usage was like 90 here, 90%. So I think it has it has done more in the initial weeks. You see here, let me maximize it. S12 product, plant 101 location ID, source ID is a bomb. S12 plant 101 underscore 001 production receipt 1. So it did production receipts of 9,000. So that means it has done more than what it can do. So the capacity utilization has gone up. So here, I mean, if I just maintain 24, and also if you have observed that it didn't even look for the available capacity, it just went and did the entire this thing. So this 999% is coming because it actually is a division between the usage and then the supply. Here there is no supply, that's why it gave a 999%, which is not true, by the way. So yeah, that's why if I maintain 24 here, then the utilization will come accordingly to how much it is. If the supply is 24, usage is 90, that means it is almost like 400% or something. Yeah, more than 400%. It's not 9999. I cannot maintain 24 here because it is the current week. I need to go into the backend and then maintain it. But yeah, the point is that it will meet the demand if you say that it is an infinite. Now I'll go back and I'll say that this is finite resource. You cannot do whatever you want to do. There is a restriction from the supply. Okay, so now another point that I want to highlight here, guys, here is that uh, usually how the supply planning works is that if there is a demand on a period t, it will try to meet the demand on the period t itself. It will not it will not do prior to period t or after period t. So if it can do, it will do on that current bucket. Then if it cannot do, you will see some shortages. Same with heuristic also. So if you say on a period 10 my demand is 1000, it will try to do 1000 on a period 10. So what I mean to say is that there are no late deliveries. You cannot deliver it late, so you have to deliver it on the same time bucket. So now you see here there is a shortage of 1800. So now with the optimizer we can say that I can take the late delivery. So if you can give me in the next 2 weeks also, that is fine to me. I mean you can meet my demand. So if that is the case, I'll come here into this key figure called as a maximum late delivery periods for customer demand. So on this time bucket I'll say that I can take a late delivery for 2 periods. Now see what happens.
Venkat, quick question.
Yes,
Do we have a
sure.
lead time also? Right? Like, we set it up for a lead time in the beginning of the beginning of time. So what happens in the lead time case for for, for optimizer? Is
Yeah, it
optimizer?
respects. Yeah, it respects the I mean, lead times are a master data element. They will be respected.
Oh,
So yeah, I mean, if you say the customer consensus demand is 1000 here on let's say, okay, this is a key of, this is week 1. This is week 1, week 2, and week 3. So this is 200, this is 300. Now let's say the lead time is 1 between warehouse and Amazon. It takes 1 week to reach the goods from here to there. So now you see here, if I say the dependent demand, that means how much of demand is coming from the customer and hitting the warehouse. So this week 1 demand is gone, because if you say like let's say not week 1, so let's say current week is 16, this is week 17, week 18 of 2019. So to meet the demand of 100, the demand has to be hit here by week 15, right? So this 100 would be gone, but week 17 200 will come to week 16, and week 18 demand will come here, this week 13. So now this would be again propagated back to your supply chain, to the plant here. Now, if the lead time is there is no lead time, then the it comes here. Dependent demand will become like this, and the production receipts would be 200 and 200, 300, and and then the transport receipts would be that it will ship the produced quantity to the warehouse. So it will reach here. I mean, it would be supply here. The transport supply is this thing, and here the transport receipts is 200, 300, and customer receipts would be 200, 300, and week 17, week 18. And if the lead time is 1 week here also, then this demand is gone. Week 17 we cannot, optimizer cannot do the what do you call it cannot meet the demand, because to produce to meet week 16 demand of 100 units for Amazon customer, the production actually should happen on week 14. So if the week 14, if it is done, week 15 it can ship it to warehouse, and from week 15 it can ship it back to the customer. So these two are gone. So this way the lead times will definitely impact our supply plan. But the moment we bring the late deliveries here, like let's say if we say a late delivery, I can wait for 2 periods, and I can wait for 2 periods, and I can wait for 2 periods here, then system would still do the production on week 16, and it will ship the goods to week 17 here, and then the actual demand of week 16 would be met in here. So the 100 would come in here. So yeah, coming back to this thing, original doubt, lead times are very well respected, but it just complicates our our analysis. So I just want to keep it simple, guys. So when we run all these ad hoc scenarios, take all these small variables and see the impact of it on the optimizer. So I didn't kept any lead times, so that we can read the results straightforward. So yeah, so you can see here week 28 8200 is there, because it cannot do more than 8200, because there is a capacity restriction. The remaining 1800 were being met on week 21 because of the late deliveries that I have maintained. Okay, so and then shortages came minus 1800, because I didn't wrote the formula nicely. I just said that it's a difference between M7 and M8. I should have kept, if this M5 is null, then only, if it is not null, then only do the subtraction. But yeah, so that is about the non-delivery. Now let's come to the transportation cost. So let's see how that will work. So 2 locations, plant 1, plant 2, sending to warehouse, warehouse. The supply is 2400. That is a maximum that it can do. That is a production capacity. So whatever it can do, it is doing it. So now let me keep some cost rates here. So I'll say plant 1 is more costly for me. I'll say it's $10. Okay, I'm saving it. So now what will happen if I run optimizer? So it will do everything from plant 2, because plant 2 is more optimal, is more cheaper. So it will take this particular lane and it will push the demand onto this side of the network. So I also change the demands here so that it makes. I'll just keep a demand of 2400, that is the full capacity, and then I'll say the 4000.
That's a $10 per piece or $10 per lot,
$10,
or
no, $10 per piece,
$10 per piece? Okay.
per unit. Yeah. So if I'm running it, so now what happens? I'm saying the demand is 2400 and it has two options: plant 1, plant 2. Based on the cost that I maintain, plant 1 is costlier, so it would pick plant 2, and the demand is just 2400. That means plant 102 can deal it. I mean, it can handle the 2400. It will do its the complete production in 102. But the next time bucket, the demand is 4000. That means the plant 2 alone cannot meet the demand of 4000, because there is a capacity limitation that it can only do 2400. And what happens to the remaining 16 no, 1600? I think there is a late delivery, guys. I think this might you know further complicate. Whatever, just keep this. Let's see, we'll see, we'll get some interesting results here. Okay. Okay. So what it did an interesting thing. So on week 20, because you said that you can deliver a bit late by 2 periods, it only did 400. And next week there are no lead times, I mean there are no late deliveries, so it met the 4000 demand in here. And week 22, the remaining it did it from here. So now let's see how that has worked out. I'm going to the transportation lane. So transportation rate is $10 on week 19. So we are in week 20, right? Yeah, week 22,400 demand. So it did 1000 in plant 1 instead of plant 2. Why? Even though it is costly, why it did it in here? I'm not sure. One second. Are there any other constraints that we have maintained? I think I maintained the production costs also. That's why it is doing a balance of stuff. So yeah, let me take off this late delivery. So it will. Let's
Do
do
you
a
have
plain
anything in a
run.
capacity? I think in a capacity, I think I think capacity you mentioned the
Hmm. Yeah,
percentages, right?
I made them as a finite. So
Oh, okay.
both the resources are finite. So let me rerun. So because optimizer does a lot of this pre-building activity. So yeah, it pre-builds and then keeps the stock at one location, and then whenever the demand is coming in, it will meet with that pre-builded stock. So yeah, let's see how without the late delivery how this will work. Have I deleted the late deliveries or not? Yes, I think I did. Okay, now got the 2400 demand has been met. Week 21 4000 has been met. Now if I come to my transportation, so week 19 it did It did the production in plant 102. So I'll also bring the production, guys. So one second, in the same view. Let's see if I have maintained any production costs also. I might have maintained production costs for 101 and 102. Yeah, production cost rates are nothing for 101. Production cost rates are nothing for 102. That's fine. So cost rates are 10 for this lane. It did a production of 2000 in plant 102, and it supplied 2000 to warehouse. But the next week, so though there is a transportation cost of $10, it still did the production from the plant 101. I think that is because are there any other settings in here? But yeah, I mean, let's not waste time. So I'll try to find out why this is coming in. But you got the theory, right? So like if you the least cost transportation would be picked up and the demand would be pushed onto the least cost transportation lane. Same goes with the production cost rate. So the least cost production would be picked up and the demand would be pushed onto that, the cheapest manufacturing option, and then system meets the demand from there. And so come back to the slides. So we have these other hard constraints. The minimum customer, all these are minimum key figures. So this is where you set a minimum to the optimizer that it follows, and then it would meet the results. And remember, when I'm saying minimum key figures, they all are at a detail level. That means at a base planning level, not at an aggregated level. So next are the adjusted key figures. So we know it adjusted how they will function. This, like, the planner is fixing the output of the supply planning to an absolute value. We have adjusted for all four: adjusted customer, adjusted transport, production, and external transit. And then the inventory corrections, storage resource capacity. It's a pseudo hard constraint, guys. It is not a hard constraint. Unlike in production resource, if I say that this is my available capacity, it will not, supply will not happen more than that. But whereas with the storage resource capacity, it can be compromised. So, and then we also have a quota arrangement key figure. So we can still say that optimizer can follow the quotas. I mean, it's not always a cost optimal approach. For example, if you have another warehouse here, and then you have another warehouse 3 here, and then the warehouse is further connected to plant 3 and plant 4. Within this space, you don't want any you don't want the optimizer to put any intelligence. So in this particular point, you can say that I want to follow my limit, my quotas as 0.6 and as 0.4. If Amazon has a 10,000 demand, if this has been pushed onto this warehouse, if it has pushed 5,000, so now take 0.6 of 5,000 and do the production on plant 3. Take 0.4 of 5,000 to the production on plant 4. So what I'm trying to say here is that even in optimizer we can use the quotas, because sometimes the planners will have more visibility and more a control, or the kind their network is kind of predictable to them. So, and they want to kind of instruct the system to follow as per the quotas. So quota arrangements are still there, so they all are part of the pseudo hard constraints. Then the soft constraints, so like all different cost, violation cost, maximum inventory violation cost, right? So this is where you will set a maximum inventory that my warehouse cannot hold more than 10,000 units for a particular product on this particular time bucket. System might if the demands are so high, if the non-deliveries are so high, system might do some inventory projections on that warehouse. But if you maintain a very high violation cost rate, then system will respect the maximum inventory condition. Next is inventory target. So this is where you set a target to your inventory and you say that I need to maintain this much of stock at this location. The higher the violation, the higher the adherence of the supply planning results. Next is non-delivery cost rate. Next is independent demand non-delivery cost rate. Just like for consensus demand, you maintain non-deliveries. Even for independent, you can maintain non-deliveries. Okay. And then we have a late deliveries and the late delivery cost rate. So that means, you know, because if you're sending it late, you'll obviously incur some cost, right? So okay, there are no I haven't maintained any costs, but if I also maintain a cost that if I am delivering this product late, I'll incur this much cost. So now optimizer again will do that, you know, a comparison that is it profitable to supply this late or not. Because if I'm supplying it late, I'm incurring this much of cost, and but how much I'm gaining, what is my revenue that I'll gain, that is non-deliveries. So, and all the supply chain costs, if system is not finding it profitable to do a late delivery, then it will not even do a late delivery. So we can influence the late delivery with the cost rates. Next is minimum resource capacity violation cost rate, and then there is also capacity supply expansion cost rate. So here the capacity supply is just 24 hours. So I can very well say that, you know, on this week 20, I can do another 6 hours more. But if I do a 6 hours more, I incur some cost because I have to pay to the laborers, etc., etc. And you can keep some costs and the capacity expansion cost rate. So now how optimizer will function? Optimizer sees that uh, the demand is high. I cannot meet the demand with the available capacity. But hey, I can expand my capacity. But is it profitable to expand your capacity? Because if I'm extending the capacity, I'll incur this much of cost. But what is a non-delivery cost? Non-delivery costs are so high. Okay, then fine. Expand your capacity. Do whatever capacity supply expansion that you mentioned. So if I say that capacity can be supplied to 10 more hours, then optimizer says that okay, now, you know, increase your 10 more hours, do more production, do more shipment, meet the demand, because meeting the demand is the most profitable one. But if the capacity expansion cost is so high, then optimizer thinks that it is not advisable or profitable to increase the capacity. Forget about the demand, just do what you can do, stick to your capacity utilization of 100%. It's okay to have some shortages, it will do that. And if there is a late delivery, then that's a different story again altogether. So we have seen how late deliveries are, you know, impacting. If it is a late delivery, then yes, system will not even go for capacity supply expansion. It will just do more production on the next subsequent period, and then it will ship the uh, the late delivered quantities, you know, lately. So yeah, so there is always this comparison between the costs when you're playing with the optimizer. So when you're doing an implementation with optimizer, so the approach is that you have to sit with the business, understand what costs really matter to that business. So sometimes, you know, some business, they won't even care about capacity expansion, so it is just fine to them. But for some businesses, the transportation costs are key, so they incur a lot of, you know, costs and etc. So, and then some businesses, they can't, compromise on their inventory targets. So because there is a high fluctuations in their demands, so they make sure that they want to make sure that if I'm putting up a target that this warehouse should have 10,000 units, optimizer has to respect it. That means the cost rates has to be so high so that the inventory targets are met. So we have to sit with the business, understand what really bothers them, what costs really matter to the business, and then, give them the priority. We have to prioritize the costs, and then, we have to set them accordingly. But planners can very well go to any particular point, and then they can change any particular, supply chain network's cost, and then they can rerun the optimizer and can get the desired results that they want. Okay. So yeah, so this constraint, so here what I'm trying, the crux is here, the some key figures are used to store time phased master data. For example, capacity supply, we have seen this. Capacity supply is actually an attribute of the type integer and part of the master data called location source. So there you maintain a static value of 24 hours, or some 6 lakh seconds, or etc. But if you want to have a time phase to it, you can make time series indicator, you can maintain it. Sourcing ratios also, I think we have seen this, right? So the quotas need not be static all the time. You make them as a time series. You will go and maintain different quotas for different time horizons. So one quarter, you can say that this this side of my supply chain, the quota is zero. Let's not push any demand onto this side. We can do all that with the time phased master data. I mean, if we make them as a time phased. Next is output coefficients. So in the bomb header there is output coefficients, and then where you say that, if you produce this bomb, that is a source id, you will create these many units of the finished good. Now you can go and change the coefficients also, so that the planner can go and update the coefficients whenever it is required for a particular time horizon. We have this maximum and then the costs. We have a fixed and variable costs, and then we also have a maximum key figures. So maximum key figures are part of hard constraints. So if I set a maximum, then system will not do more than that. So we'll see it, guys. I mean, tomorrow we'll touch base on this maximum key figures and minimum key figures, and also lot sizing procedures is pending. So we'll also cover that, and some other scenarios and push deployment and pull deployment and etc. We'll cover that tomorrow. So
Do you have
any
a class
doubts?
tomorrow, Saturday?
Oh yeah, so we don't have a class. Sorry guys. So yeah, on Monday we'll have a class. So yeah, we'll touch base
Sure.
on Monday.
Monday morning is a Sunday night for us.
Okay. Yeah.
Yeah. So you want a session or you don't want a session?
I'm traveling actually. My flight is at 8:30 night.
Okay. Yeah,
If
then fine.
there is a
So
class, I would like to go an early flight and then try it, but I have to change my flight.
okay. So uh,
It's up to the team. Like, and I don't want to just hold up too much just because of for me.
can we not have a session on Sunday night? Okay, that means Monday morning. Okay, guys. So let's not have a session on Monday night, and we'll see, like, if we can also do it on weekends. So we'll try to push on weekends also. Not this weekend, but going forward. So yeah, so we'll not be having a session on the Saturday and Sunday and Monday Indian time.
Okay. Thank you. Thank you.
Yeah, and I'll send an update to all you guys through the meeting coordinator. I'll update him so that he'll send the.
Srinivas.
Hey Srinivas.
Actually, I received the videos from the team, but I did not receive any documents. Like what are the you are showing in the presentation?
Yeah. The documents will share it, Srinivas. Yeah. So it needs to be fine tuned again. So we have to beautify them more, and then we'll share it. We'll share it.
Okay. And actually, if I want to run one supply session in this weekend, can I go through your videos, all the videos?
Yeah. Please, very well. Please go on and talk to your
So in the
meeting. I mean,
session,
hmm.
so in the session, in the previous session, you have covered, like you told you have covered all the master data, what we need to maintain and how to maintain that one.
Yeah. Yes. So I would suggest you that go to the link, and then if you have any doubt, just please make a note, and then reach out to your meeting coordinator. We'll see what we can do. We'll definitely clear all the doubts, whatever you have.
Thanks.
Yeah, and funny, are the alerts similar to what we have in APO? Any better, any new or better? I'm not sure whether you have seen the custom alerts that we have talked about. Mm, right, that is a kind of a fancy feature. So this one, we created a new alert. We gave a definition, alert definition, that if key figure X is greater than key figure Y, or like all those mathematical comparisons, and then we can create an alert. We can share that alert to the users. We can subscribe to that alert. We can see an overview of that alert, and then we can prioritize an alert, whether it's a high priority or low priority or a medium. So if I go to this app
You can
custom
also
alerts
put in a
for
case. Also, you can create a case.
yes, great, thanks. Yes, so yeah, so funny that's a custom, that's a web-based alert. And then now the key figure alerts, we have to if the business is clear about the condition and etc., so we have to write a calculation for it. So that happens in the model configuration. So I'm thinking, guys, like once the supply planning is done, we'll start with the model configuration. Like we'll start from the scratch, how to create an attribute, how to create a master data, how to create a key figures, and we will do that. We'll spend almost a week on building the model. So there, when we are building the model, when we reach the key figure topic, so there are different types of key figures. One such key figure is an alert key figure. So there we'll configure an alert, and we'll write the calculation, like alert condition will write. And then once that it is activated, then we can use that alert in the planning views, or in anyone can use it, because that is a planning area element now. It is not end user made this thing. That's a configurable element. So we'll see that. And the ease of writing a alert definition also will say it. It's kind of smooth. Okay, guys, then next session we'll dig deep into the optimizer scenarios. We'll take the scenarios, and then we'll see how different costs will impact, and also we'll cover the lot sizing procedures. So yeah, and then after that we'll start with the model configuration. We'll start with creating a planning area and all that stuff. Then once that is done, then we'll get into the other modules like demand planning module, inventory optimization, and sales and operations planning, etc. Okay, thanks guys,
So
thanks
next
for your
session
time.
on Tuesday, right?
Sorry,
Next session is on Tuesday, right? Tuesday IST.
Tuesday. Yes, Tuesday IST. Yes.
Yeah, okay. Thanks, sir.
Thanks guys. Yeah, bye.
Thank you.
Thanks.